Welcome back to the deep dive. Today, we're charting a course into the future of shipping, a really big one.
Yeah, we're looking at how goods move around the world, specifically through the lens of the UK's, well, frankly, ambitious plan for maritime autonomy.
Right, this is the Department for Transport's 2050 strategy we're digging into. And it's not just tweaks, is it? We're talking self-piloting ships, automated ports.
Completely automated ports, potentially, and a massive shift in the whole supply chain. Think AI, think robotics running the show.
So what's our main source for this? Just a high-level plan?
No, much more concrete than that, actually. We've got a detailed route map here from early 2019. It's designed to work alongside the bigger Maritime 2050 strategy.
Okay, so the 2050 strategy is the what, and this roadmap is the how.
Exactly. It translates that big vision into actual policy steps. Commitments from government, commitments from industry, short-term, medium-term. It's basically the playbook.
Got it. So our mission today is to sort of unpack this playbook for you, our listener. How does the UK really plan to become a world leader in, well, smart shipping?
Yeah, we need to get past the buzzwords. What's the real plan for the tech? What about the infrastructure needed? You know, the physical stuff, the organizational stuff.
And the people, right? The skills needed. Plus the really big one, how do you regulate these autonomous systems? Make them safe, legal.
Absolutely critical. And it couldn't be more timely. The foreword in the document, the ministerial foreword, actually calls it a pivotal moment for technological development in maritime.
A pivotal moment.
Right.
So why now? Why is autonomy suddenly so important?
Well, the promise is huge. Cleaner operations, safer working conditions, much higher efficiency. That's the goal.
And it changes the jobs too, presumably.
Massively. The idea is to automate the dull, dirty, dangerous tasks, you know, the repetitive or high-risk stuff, and hopefully create new high-value jobs instead.
High-value jobs like those
Ah.
data analysts, systems controllers.
Exactly. People managing the data, overseeing the systems, maybe operating things remotely. It's a different kind of maritime career.
Okay, let's set the scene first, the economic context. Why this massive focus on the maritime sector specifically?
Because it's absolutely fundamental to the UK economy. I mean, the numbers are staggering. The source says 95% of all UK trade travels by sea.
95%, wow.
Yeah, virtually everything. So economically, back in 2015, it was contributing about 14.5 billion GVA directly.
GVA, gross value added.
Right, and employing around 186,000 people. It's not a small part of the economy. It's like the main artery for trade.
So this isn't just about keeping up, it's reacting to something bigger.
It is. It's the UK's answer to the fourth industrial revolution. You know, everything becoming connected, cyber-enabled systems, AI, robotics.
The whole digital transformation wave.
Exactly. And the UK recognizes, look, if we don't lead on this in maritime, define the standards, someone else will, and we could lose our edge.
Okay, let's get precise on terms. Maritime autonomy. What does that actually mean in practice? We hear MASS maritime autonomous surface ships.
Right. So MATIS, the basic definition is equipment operating and making decisions without a human crew actually on the vessel in the marine environment.
Okay. But it's not just one thing, is it? The strategy talks about different levels.
Yeah, crucially, it's a spectrum, not just fully driverless ships overnight. The source outlines 4 main levels of autonomy.
4 levels. Can you walk us through those, maybe using that Lloyd's Register scale, AL0 to AL5?
Sure, that scale helps. AL0 is no autonomy, AL5 is fully autonomous. So the first level in the strategy is basically vessels with augmented human capabilities.
So tech helping the humans on board.
Pretty much. Think decision support, better collision warnings, maybe systems that optimize fuel use. The crew's still there, fully in charge, but they have smarter tools. That's low down on the AL scale.
Okay, making the existing crew better. What's next?
Next up is vessels with fewer crew. This is where automation starts taking over specific tasks, the dull, dirty, dangerous ones.
Like automated engine checks.
Or robotic cargo inspections, maybe. Stuff that reduces the number of people needed at sea, especially for risky jobs. Still humans on board, but fewer of them and doing different things.
Right. Then things start getting really different. Yeah, the third stage is the big step. Unmanned vessels controlled remotely from shore. This is what they call remote operation. So the ship drives itself, but someone's piloting it from an office.
Essentially, yes. A qualified person, but they're potentially thousands of miles away using a high-speed data link. The human presence shifts from sea to land.
Okay. And the final destination, the AL5.
That's the fully independent vessel, AL5. Here, the machine makes all the decisions. Navigation, collision avoidance, handling bad weather, docking. all without direct human control in real time.
Wow, that raises so many questions about safety liability.
Huge questions, which we definitely need to get back to when we talk regulation.
But the strategy also uses the term smart shipping. Why differentiate that from just autonomous vessels?
Because the vision is broader than just the ship. Smart shipping covers the whole sector's tech journey. It includes automation, digitized equipment, remote operation, and full autonomy. And crucially, it applies both at sea and on shore.
Ah, so it connects a port, the logistics, everything.
Yes. The strategy really pushes this holistic idea. It's about the entire UK supply chain, door to door. You only get the full benefits if the whole system is smart, not just the boat part.
Okay, so if they pull this off, this integrated smart system,
Yeah.
what's the prize? The economic carrot.
It's massive. Globally, the forecasts mentioned in the source suggest a market for this stuff. Maritime autonomy, smart systems worth around $136 billion over the next 14 years or so.
$136 billion, that's huge.
It really is a whole new economic sector opening up.
And the UK's ambition, what slice of that pie are they aiming for?
They're aiming high,
Yeah.
leveraging their strengths maritime law, finance, design, tech platform. They're targeting a 10% market share.
10%, so roughly $13.6 billion.
That's the goal. This route map is basically the plan to capture that share, make the UK the place to be for smart shipping innovation.
Okay, a $13.6 billion target. That definitely focuses the mind. But how do you actually build the foundations for that? Let's talk infrastructure,
Yeah.
organization.
Right.
The vision is all-encompassing. Lead in design, manufacturing, using the tech, the skills, the regulations, become the destination of choice for innovators worldwide. That sounds like it needs serious coordination. Government, industry, researchers, all pulling together.
Yeah, it is.
Does. And that's where the key organizational piece comes in. The proposed Center for Smart Shipping, or CSmart. CSmart. Okay, what's its job?
It's meant to be the central hub, the single point of contact between government and industry. Its role is to oversee implementation, coordinate all the different bits of work going on, support big industry projects, basically be the conductor for the whole orchestra.
So preventing everyone from just doing their own thing in silos.
Exactly. It's designed for a cross-sector approach. The document even mentions learning from how the aerospace industry handles R&D and commercialization safely.
Interesting parallel. Aerospace.
Yes, CSmart's job is to bridge that infamous valley of death, getting great UK research out of the lab and into the actual market.
Okay, that's the organizational structure. What about the physical world? The ports, the coastline? The document made a point about smart ships needing smart surroundings.
A really critical point. Smart shipping's potential is severely limited if the ports and infrastructure stay dumb or analog.
And ports are the key nodes here.
Absolutely. They're fixed points, handle huge volumes. What was it? 112 million tons of freight in just Q1 2018. And their infrastructure lasts for decades, so they have to modernize.
Modernize how? What tech needs to go into the ports?
Think full digitalization. Sensors everywhere, the Internet of Things, robotics and automation for moving cargo, digitized paperwork, customs, scheduling. Everything needs to talk to everything else, including the incoming autonomous ship.
And to actually try this out in the real world.
The plan is for government and industry to set up a UK maritime innovation hub within an actual UK port.
A physical test bed.
Yeah, a place to bring together the experts, the tech people, the port operators, the regulators, network, collaborate, and actually test autonomous systems safely, both on land and on the water, like testing automated cranes alongside vessel docking procedures.
Okay. And then there's the human control aspect shifting onshore, the shore control centers.
Right, these are totally new types of facilities. Instead of a bridge on a ship, you have these centers where human operators remotely control or monitor the vessels. It's a huge operational shift.
How do they plan to figure out how these centers should actually work? The practicalities.
Well, the route map suggests setting up a demonstrator shore control facility.
A pilot project.
Essentially, to really understand the nuts and bolts. What are the tech requirements? Bandwidth. Latency issues in bad weather. What about the human factors? Can one person safely monitor 5 ships? What are the legal implications if something goes wrong? The demonstrator is for gathering that hard evidence.
Before we dive into the core tech, we have to talk cybersecurity. You connect everything up, you create vulnerabilities. The Maersk attack is mentioned.
And it's a stark warning that 2017 NotPetya attack cost Maersk at least $300 million. And that was primarily their IT systems booking, scheduling.
Right, but what if an attack hits the operational technology? The system's actually steering the ship.
That's the nightmare scenario, isn't it? An autonomous ship hijacked or sent off course or disabled. The potential cost in lives, environmental damage. It could dwarf that $300 million figure.
So what's the plan to counter that threat?
It's about continuous work with security services, the National Cybercrime Unit is mentioned, and building on existing guidance. They issued specific cyber guidance for vessels back in 2017, but it's clear that building resilient, secure digital infrastructure isn't just nice to have, it's absolutely fundamental for safety and trust.
Okay, so we have the why, the economics, and the where, the infrastructure, like CSmart, the port hub, shore control centers. Now let's get into the how. The actual technologies making this possible.
And the UK feels it's starting from a pretty strong position here. The digital sector was already worth over 130 billions back in 2017.
And government sees this role as helping tech cross that valley of death.
Exactly. Using things like the Catapult Network, UK Research and Innovation, UKRI, it's about turning research into products. There's already been investment, too, like NERC putting £17 million into autonomous systems in 2017.
The route map highlights 4 key technologies, right? And they all depend on each other, completely interdependent. It's an ecosystem. Sensors, data, AI and machine learning, and robotics. You can't really have one without the others working effectively. Let's break them down, starting with sensors, the eyes and ears.
Pretty much. Sensors measure the physical world weather, sea state, what's around the ship, and the ship's own condition engine health, hull stress. They provide the raw data. Without good sensor data, autonomy is just blind.
And advanced sensors allow the ship to see and react.
Yes, combined with machine learning, advanced sensors let the system recognize other vessels, navigation marks, even specific cranes in a port, and interact safely. But the source mentions a big challenge: marinization. Making land-based tech tough enough for the sea. Ah, yes, marinization. This is a huge practical hurdle. The marine environment is incredibly harsh. Saltwater corrosion, constant vibration, shock from waves, extreme temperatures.
And things growing on the sensors, biofouling.
Exactly. Barnacles, algae. They can quickly block or degrade sensor performance. So you can have amazing sensor tech developed on land, maybe at places like Sensor City and Liverpool, but making it reliable and long-lasting out at sea for months without maintenance, that's a major R&D challenge. Okay, so sensors provide the raw input. Next comes the fuel, data, big data. The scale sounds immense. It's astronomical. Lloyd's Register Foundation estimated something like a 4,300% increase in data generated annually by 2020. Autonomous ships are constantly streaming data.
And the UK is well placed to handle this data deluge.
Supposedly, yes. Largest data center market in Europe, a big data analytics industry, predicted to be worth maybe $241 billion by 2020. So the capacity should be there.
How does all this data translate into practical advantages at sea, beyond just navigation?
Well, obviously, autonomous vessels need vast data sets just to operate safely. But a huge benefit is predictive maintenance.
Fixing things before they break.
Precisely. Instead of routine dry docking, analytics can predict when a specific pump is likely to fail, allowing targeted maintenance. That saves a lot of money, reduces downtime, and boosts safety.
Right, and the engine processing all this data fuel, AI and machine learning.
This is the core intelligence. Machine learning getting computers to act without explicit programming is what enables autonomous decision-making. And the UK sees massive potential here. Figures like AI adding $630 billion to the economy by 2035 are thrown around, leveraging strengths from companies like DeepMind or SwiftKey.
And in maritime, AI isn't just about the self-driving aspect.
No, it's much broader. Yes, it's essential for safe navigation and collision avoidance, but AI also acts as a huge booster for the shore-based teams, optimizing routes based on weather, fuel prices, cargo needs.
Helping humans make better decisions, basically.
Exactly. Or even helping, say, insurance experts analyze complex accident data, or maritime lawyers interpret regulations in light of new situations. It augments human capability.
Okay, sensors, data, AI. The fourth pillar is robotics. The physical action part.
Yeah, robotics is about performing complex actions automatically. It's ideal for the harsh marine environment, taking humans out of those dull, dirty, dangerous roles.
We see some automation in ports already, like cranes.
Automated gantry cranes, yes, but the future is robotic inspectors, maybe underwater repair units, autonomous support vessels. The UK robotic strategy sees potential up to $183.6 billion over 10 years.
And again, that marinization challenge applies, making robots seaworthy.
Absolutely. CSmart is specifically tasked with working with the UK's robotics network, the UK RAS network, to figure out how to adapt sophisticated land-based robots for reliable operation at sea.
To speed all this tech development up, the route map suggested a couple of specific actions: hackathons and accelerators.
That's right. First, running hackathon-style events. Get tech people and maritime people in a room together to rapidly tackle specific industry problems. Quick, focused innovation.
Breaking down silos again?
Yeah. And second, exploring a joint government industry business accelerator specifically for maritime autonomy startups to help get that promising UK research funded and out into the global market.
Okay, that covers the tech pillars. But what about the people in this new picture? Automation always raises questions about jobs.
And this is crucial. The route map really emphasizes that people are still central. It's about evolving roles, not just replacing humans wholesale.
But there is anxiety, right? The
Yep.
document acknowledges that.
Oh, definitely. It cites an IMRS survey showing almost half of UK seafarers were worried about autonomous shipping's impact. And there's also that perception issue. About 20% of maritime professionals felt the tech people didn't fully get the realities of working at sea.
That disconnect is risky. Building tech that doesn't work in practice. So what's the positive vision for the workforce?
The message is that tech is a force multiplier. It should lead to upskilling, potentially better paid jobs, and importantly, a shift away from long, dangerous periods at sea towards more shore-based roles. Easier on people physically and mentally.
So instead of swabbing decks, you're managing systems from a control center.
Something like that.
Mm.
Or analyzing the data streams or ensuring the algorithms are performing correctly. It's a shift towards higher-level oversight, systems management. We're talking remote pilots, data auditors, algorithm testers, different skill sets.
But to fill these new roles, you need new talent. And the document mentions sea blindness.
Yeah, sea blindness. The idea that the general public just doesn't see or appreciate the maritime sector, it's sort of invisible, which makes it hard to attract young people, especially into the tech-focused roles the future demands.
So the solution involves marketing, selling the sector as high-tech.
Exactly. A coordinated industry marketing campaign, an ambassador program in schools focusing on STEM subjects, trying to showcase the modern, innovative side of maritime, led by one industry body for consistency.
What about the current workforce? How do they keep up during this potentially 30-year transition?
Lifelong learning is the key phrase. Promoting continuous professional development, making sure current seafarers get the training and gain confidence with the new technologies.
Using new training tools as well, VR and AR.
Yes, places like Warsash Maritime Academy, City of Glasgow College are encouraged to use things like augmented reality and virtual reality simulators more, so crews can train on complex new systems before they even hit the water.
And who ensures the training actually matches what the industry will need in 5 or 10 years?
That's the job of the Maritime Skills Commission. It was set up as part of the main Maritime 2050 strategy. Its task is to regularly assess skills needs, say, every 5 years, figure out what training is required for the future, getting input from CSmart on where the tech is heading.
And finally, bridging that gap between the seafarers and the technologists, mentoring schemes.
Yeah, that's an interesting one. To build trust and make sure the tech is designed with users in mind, CSmart is meant to oversee cross-sector mentoring schemes.
Pairing maritime people with tech experts.
Exactly. Maritime workers, trainees, paired with experts from, say, automotive or aerospace sectors that have been through similar changes, and also with futurists. Sharing best practices, making sure the human element isn't forgotten in the tech rush.
Right, we've got the tech, the infrastructure, the people,
Okay.
but none of it works if it's not legal or safe. Regulation. Industry called this a major barrier.
It really is the potential bottleneck. Technology, especially AI and software, moves so much faster than international lawmaking. The rules need to be flexible enough to cope, but robust enough for safety.
So how does the UK plan to tackle this domestically first?
By setting up the Maritime Autonomy Regulatory Lab, MAR Lab, this will be run by the main regulator, the Maritime and Coast Guard Agency, MCA.
A regulatory lab, like a sandbox.
Pretty much, a place for innovators and regulators to work together, discuss new ideas, test things out, identify where the current rules don't work or create barriers, and figure out new approaches based on evidence.
What's the initial focus? Trying to regulate giant autonomous tankers straight away.
No, much more pragmatic. Initially, the focus is on developing rules for testing and operating smaller vessels, those under 24 meters within UK waters.
Lower risk, faster learning.
Exactly. Test the core technologies, navigation, collision avoidance, remote control in a controlled way. And the government commits to keep allowing testing in different UK locations, giving case-by-case advice.
And the goal is to attract companies here to do that testing.
Yes, make the UK the flexible, practical place to safely test and develop these systems, the destination of choice again.
But shipping is global. Domestic rules are only half the battle. How does this MR lab experience feed into international rules at the IMO?
That's the explicit link. The plan is to use the evidence and experience gained domestically through MR Lab to lead the discussions at the International Maritime Organization.
Shape the global rules, not just react to them.
Precisely. The UK aims to be a really active player in the IMO's work on mass S regulation, working with other countries to build consensus on safe, secure, environmentally sound international operation.
So the UK tests small boats locally to build the case for regulating big boats globally.
That's the strategy. Gather the data, demonstrate safety, understand the risks, and then use that knowledge to push for international guidelines. Starting with things like rules for international test voyages for larger remote and autonomous ships, it's about using domestic innovation to secure long-term influence on global maritime law.
Okay, so wrapping this up, it's clear this is a really joined-up strategy. You've got CSmart coordinating, MAR lab handling the rules, and this focus across infrastructure, tech, people, and regulation. It's a huge undertaking.
It really is. A complex, long-term plan aimed squarely at that big economic prize, that $13.6 billion slice of the global market.
But as you said, and the source stresses, it all hinges on government and industry actually working together, closely, continuously.
Absolutely. This isn't something that just happens. It needs constant effort, collaboration, investment. It's a pathway towards those big maritime 2050 goals, but the journey requires everyone pulling together.
So a final thought for you, our listener, to ponder. We've heard about the short-term focus on hackathons, setting up CSmart and MR Lab, and the big challenge of marinization. How quickly do you think this UK lead in domestic testing can realistically translate into globally agreed rules at the IMO?
Yeah, and think about that tech challenge specifically. You have incredibly sophisticated AI, maybe from companies like DeepMind, trained on relatively ordered data. Now you put it on a ship in the middle of the ocean, chaotic weather, unpredictable encounters, maybe needing to break a rule like call regs to avoid a bigger disaster.
How does the slow pace of international law handle an AI making that kind of split-second, potentially rule-breaking safety decision?
Exactly. How quickly can global governance adapt to that level of machine intelligence operating in such a complex, high-stakes environment? That gap between cutting-edge tech capability and the global regulatory framework might be the biggest hurdle of all.
Something to definitely think about as this autonomous future unfolds on the waves.